Trigonometry, section 5.5, the double angle formulas, or the double angle IDs. Okay, first of all, the sine of 2a, we want to be 2 sine a cosine a. It's going to be the one that you put into your, I guess, for your trig quiz. How do you get that? Well, let's see here. Sine of 2a is the sine of a plus a. We're going to use our sum and difference angles for this. So this is the sine of a, the cosine of a, plus the cosine of a and the sine of a. We can change the order here though, so we really have 2 sine a cosine a's. Because of the commutative property, we change these so they both look the same. For the cosine of 2a, we have 3 versions. It's going to be, let's try this, cosine of a plus a, which is the cosine of a minus the sine of a, sine of a. So this is really cosine squared a minus sine squared a. And that is the first form that we'll use. Then we're going to split this into 2 different forms. Remember, you might be thinking to yourself, if the sine squared of a plus the cosine squared of a equals 1, then what does cosine squared equal? Well, cosine squared equals 1 minus sine squared a. And what does sine squared equal? Well, sine squared a equals 1 minus cosine squared a. That's probably what you're thinking. So let's replace the cosine squared with the 1 minus sine squared. So it's 1 minus sine squared a for the cosine squared minus sine squared a. So it's really 1 minus 2 sine squared a's. That's another form. Replace the sine squared with the 1 minus cosine squared. So it's cosine squared a minus 1 minus sine squared a, I'm sorry, cosine squared a. And so you have cosine squared a minus 1 plus cosine squared a. Now these then add together 2 cosine squared a's minus 1. And that's the third form. You'll be asked for all 3 of these forms. And then we have the tangent. The tangent of 2a is the tangent of a plus a, which is the tangent of a plus the tangent of a over 1 minus the tangent of a times the tangent of a. So tangent plus tangent, there must be 2 tangent a's up there. Tangent times tangent, 1 minus tangent squared a. And that's the one we use for that. So these are the new identities from section 5.5. I'm going to try to go through several problems as examples. If you have one from the homework, let me know and I'll make sure I include that. Have a good day. Let's do a practice problem from Trig, section 5.5. How about number 14? It's on page 236. We're supposed to find the value given in the value in this angle. So they're saying it's just theta. So sine theta, we're supposed to also find cosine theta when we're given that the cosine of 2 theta equals 3/4 and theta is in quadrant 3. Okay, many times a picture can help you get most of this stuff without going through a lot of calculations, but in this case, we want to find the sine of theta when we're given a 2 theta situation. So we got to knock that down to a theta situation. I'm going to use 2 cosine squared theta minus 1 to replace the cosine of 2 theta. We did have 3 choices. And if that equals 3/4, add 1, so 2 cosine squared theta. Well, 1 is the same as 4/4, so this is 7/4. 4/4 and 3/4. Divide by 2 or multiply by 1/2. So these 2's cancel. Cosine, this is not, let's see, cosine squared theta, and this is 7/8. And take the square root of both sides, the cosine of theta, but this is where you get the plus and minus, 7/8. Well, how do we know whether to choose plus or minus? Well, theta is in quadrant 3. Let's draw a picture. And if theta is in quadrant 3, then both sine and cosine are negative. So we're going to use the negative part of this. Let's rationalize the denominator. Cosine of theta is negative square root of 7 over the square root of 8. And if we multiply, I guess we can reduce it that way. Multiply both square root of 8. We get the negative square root of 56 over 8. Well, let's see here. 56 is 7 times 8, which is 2 times 4, which is 2 times 2. So I can pull out a 2 and leave a 14. But now we can cancel this a little bit. This is going to be over 4. So that's what the cosine of theta is. Negative square root of 14 over 4. That's this, negative square root of 14 over 4. Well, hold it. We can say this is the adjacent over the hypotenuse. So let's make the hypotenuse 4. Now, this is my y. And so y squared, leg, plus a negative square root of 14 squared, the other leg, equals the hypotenuse squared. Y squared plus 14 equals 16. Y squared equals 2. So y must be plus or minus the square root of 2. Well, hold it just a second. Third quadrant, negative. And to get your answer up here, the sine is the opposite, negative square root of 2 over the hypotenuse 4. So, we did use an identity, but we didn't have to use too many, and it wasn't too bad. So, another example problem. This is number 28, page 237, and from 17 through 36. These are all verify the identity problems. So once again, stick on one side only. Have your identity sheet out if you need to remember this stuff. And we'll see if I can show you how I would do this one. We really don't have a lot of identities for the cotangent, but we've got some identities for the tangent. So I'm going to change this into 1 over the tangent of 4 theta, which is the reciprocal identity Now I've got several for double angles for the tangent, but nothing for a quadruple angle, but that's okay, because the double angle, if you take a 4 times, it'll bring it down to a 2 times theta. And so this is 1 over. Now remember, what I'm really thinking here is 2 times 2 theta is the 4 theta stuff. That's so the identity where the tangent of 2a is 2 tangent a over 1 minus tangent squared a. Gosh, if you could read that. That's what I'm using. But a is now 2 theta. So it's 2 tangent 2 theta over 1 minus the tangent squared 2 theta. Hopefully that makes sense. And what's nice is, because this is 1 over this fraction, you can really write this as the denominator 1 minus tangent squared 2 theta over 2 tangent 2 theta. And that's what we wanted. QED. So while I've got you here, let's do another one. 36 on the same page, page 237. And these are all scattered in here as far as the identities. We need to get everything down to cosines though. This is the more complicated side, it looks like. And we need to get on cosine squared. So we're going to do several things. Cotangent, I may leave that alone for right now, but the tangent is going to be of a sum. Tangent of theta plus the tangent of pi over 1 minus the tangent of theta times the tangent of pi. The sine of a difference, it's the sine, and I better put parentheses because we're subtracting this. The sine of the first, the cosine of the second, minus the cosine of the first, the sine of the second. Now I'm going to continue this down here. That's the sine. This is going to be times the cosine. This is multiplication between here of that first cosine of the first, pi over 2, cosine of the second, theta. Subtraction becomes addition with the cosine of the difference. This is the sine of the first times the cosine of the second. I'm sorry, the sine of the second. And that's supposed to get to cosine squared somehow. My gosh. So we're multiplying these two together. Let's substitute some of these actual values, right? You remember, for these angles, pi and pi over 2, we're just worrying about these two spots on the circle. This is the ordered pair, 0, 1. And this is a negative 1, 0. And this is the pi over 2, and this is the pi. So, with that information, because r is always equal to 1 for this unit circle, we've got the cotangent of theta. That doesn't change. The tangent of theta doesn't change. What is tangent of pi? Well, the tangent is y over x, 0 over negative 1. So this is plus 0. And this is 1 minus the tangent of theta times 0. Because this is pi. The sine of pi is just the y, which is 0, times the cosine of theta. That's going to disappear. Minus the cosine of pi, which is a negative 1, times the sine of theta. And what is the cosine of pi over 2? Well, the cosine of pi over 2 is the 0 times the cosine of theta, plus the sine of pi over 2 is 1 times the sine of theta. Okay, So we can take care of all this stuff. Cotangent theta, this is the tangent over 1, or just tangent theta, because this is times 0, minus, well this is 0, and this becomes positive, but then it's negative. So this is a negative sine theta. And that's times, this is 0 and this is sine theta. So the cotangent, if you'll remember, is the sine of cosine of theta over the sine of theta. The tangent is the sine of theta over the cosine of theta. So this cancels this and this cancels this. It's really 1 minus sine times sine is sine squared theta. So if you think of that, we had an identity, the Pythagorean, if sine squared theta plus cosine squared theta equals 1, then cosine squared theta is 1 minus sine squared theta, and that's what we need. Cosine squared theta, which is exactly what we wanted. QED. Okay, Trig, another example problem on page 237 for those problems 37 through 48. This is 44, and all it says is simplify, which is not great instructions, but what you might recognize here is the double angle for tangent. The tangent of 2A is 2 tangent A over 1 minus tangent squared A. So this A is like the 34 degrees. We just don't have a 2 here. And if we want to put a 2 tangent 34 degrees over 1 minus tangent squared 34 degrees. Oh man, I got too many parentheses. Anyway. Well, we also have a 2 down here. And if we put in another 2, we got to sort of get rid of it by having another 2 down here. Does that make sense? Because we got to make sure that we, this 2 is the original one. This 2 gets rid of that one. We're really just multiplying by 1. And that's what's important here. So all of this part is just, now it's 1/4. This is the tangent of 2 times whatever the A was, and it was 34 degrees. So it's 1/4 tangent 68 degrees. And that's what they mean by simplify. Let's do one more on this same sheet of paper. For these problems 57 through 62, it even applies to those through 68. These write as a sum or a difference. The ones through 68 is write as a product. And what they're referring to are those identities that we didn't memorize. At the back of your book, they have these listed here for almost everything you want. These are the product to sum and sum to product identities. We didn't memorize these. We don't use them as often as other things. But every once in a while you say to yourself, hopefully, I remember in Trig, I needed to change a product to a sum, or a sum to a product, either the way. For these, we need the sine, because we're doing number 62 with sine. So the sine is sine A sine B. That equals 1/2 cosine A minus B minus cosine A plus B. And these are so similar, sometimes you get a plus or minus sign messed up. I always have to look them up, so that's why we don't memorize them. But A and B are the 7x and the 9x, so this becomes 8 times the 1/2 times the cosine of 7x minus 9x minus the cosine of 7x plus 9x. So we get a 4 instead of 8. This is the cosine of a negative 2x minus a cosine of 16x. When they say change it to a sum or difference, you don't have to go too much further. This is 4 cosine, and because the cosine of a negative angle is the same as a positive angle, we can just write that, minus cosine 16x. Oops, 4 cosine 16x. So we've changed this into a difference.